Hi, this is Nathan Tintle. In this learning goal video, we will talk about how whether you use the slope or the correlation coefficient as your statistic, you'll get the same conclusion. We'll use the GPA and non-academic hours data set to talk about this learning goal. We're showing you here the result of the same simulation, the same shuffling of the response variable, and using the slope as the statistic and then using the correlation as the statistic. The take-home message is this. You change the statistic, so you change when you simulate the value of the statistic that you save each time, that you keep track of. In the graph on the left, we see that a slope of negative 0.0059 or less occurs about 4% of the time in this set of 1,000 simulations. If you click a different button at the top of the applet and you go to correlation instead, what this means then is, for the same 1,000 simulations, let's compute the correlation each time, keep track of that. Now what do we need to change? We need to say, well, how often does the actual correlation, which was negative 0.29, or less, occur if the null hypothesis is true? It's the same 4%. That will always be the case. You get an identical p-value, whether you use the slope or the correlation to do your simulation. One final comment. If the slope is 0, then the correlation is 0. A slope of 0 and a correlation of 0 are implied if there's no association. So when you do the simulation, yes, typically the value of the statistic will be different. The slope and the correlation coefficient are not the same thing, but they are both 0 at the same time. If it's non-zero, then the values almost always will not be the same.